It's Roger from Mud Fossil University. Today, after 2 years of posting about light and energy and working with all of the different interactions, I believe now it's time to be peer reviewed. I asked for it 2 years ago, was peer review on the particle theory that I have and the spinning vortex theory. It covers really universality now. And I have been kept away from any academia for 2 years. They completely refused to respond. And I think it was because of things like this, where these people tried to they literally took my research in another area, called it their own, and then started talking about flat Earth. So that really knocked me out of the entire, then I became very, not credible in the eyes of academia whatsoever, so they discounted me. And it certainly is not my theory. And then I was attacked by the flat Earth people because I wouldn't agree with flat Earth. So I've been sidelined. So it's time to take a look at this, because what I will present is very, very sound. Okay, just remember these shots. This is a light wave. You see it as presenting a big fluffy disk, but it's actually only particles in the very center illuminating and creating a field, which also illuminates other particles that are near it because it's expanding into that region, and these are becoming illuminated. Not like these, but they are displaying energy. That light wave, and you can see the tiny little beam of power coming out of it, is there being crushed now because it's being accelerated into a venturi of two metal pins here. As it comes in, it forces these tiny little electrons into each other's regions and accelerates them and crushes them, turning them into plasma, exploding out the other side of the venturi, creating Cherenkov radiation, which stops about here, and they start to display these little patterns, are the fibrils of light, and they are what is called the boson, which is a charged particle flowing through the air. And as it flows through the air, it creates a magnetic field, and that field crushes itself into what they call the ocean of atmosphere, which I have another word for. This is directly above the accelerator, showing that the particles now have invaded each other's regions, and they're like balloons expanding, crushing, and forcing themselves into plasma, coming back and starting to step down and relieving themselves of that energy to some degree, and then they begin to spin back into their normal light patterns. Looking into the accelerator, we see these disks and those little tiny fibers of white filaments coming out, which I said are the charge carriers. They come for a certain distance, and then they present fields. And I will show you the presentation of fields. You can see them here. And you can see they're different colors, which means they're different frequencies, which means there are different intensities. And you can see this is a more dense disk than that. This is a highly accelerated particle, and I believe it's spinning backwards, and I'll explain that. This is the Cherenkov radiation, which happens when light is accelerated. It's called electron shower, neutrino electron showers. I'll show you that. Now this is not a good, every now and then it's hard to get this in focus correctly, but hopefully you can see those disks and what I explained. And all of the little dots and particles are the ether that is polarizing all of the particles in the air. The particles in the center, all the particles in the air are being polarized, and that disk is moving out now with that particle, which has now started to make these disks. And this is coming out of the accelerator, stepping down, and this is the presentation of the two disks of particles. Well, I feel that I've shown that light is particles, and I have pretty much displayed that, which means that light, when it travels from the sun to the earth, is still those particles. They do not react with each other because in the absence of nucleated particles, which means complete matter. They have nothing to bounce off of. They're all negative, they stay apart from each other, and they come towards Earth as these negative particles. In space, they're dark energy and dark matter. And that has a consequence, because they are negative particles, and as everything spins through space, it crushes and rubs against those negative particles, causing every single anomaly that we see in Venus. 200 days to spin one time in a circle, and to spin on its axis 200 days, because it's trying to force against the ether, where it's going backwards against, it's crushing its magnetic field into itself. It has no magnetic field, just like that white particle that I showed had no magnetic field. It spins in reverse, just like I'm claiming that white particle does. And that's the only way you can get that kind of power with no magnetic field. It's hotter than hell at the axis, at the equator. And at the poles, it's extremely cold. It's 800 or almost 900 degrees at the equator, and it's minus 250 at the poles. It's pulling the electrons out of the poles and scrubbing them off, and then they just float through space. They're being ripped off and it's dense. It's a dense atmosphere, 92 times, I believe. And that's because of the ether crushing it against the planet. It glows. It's being violently crushed. It's heated. It's glowing from this crushing into the ether. All right? There's no magnetic field. It's because it's spinning backwards. All right? So that's what we're seeing, and that is what I just showed in that light experiment. This is not something that, there's all kinds of evidence to back up the things that I am saying, and nobody else can account for this until you throw the ether in. Once you throw the ether in, everything just is totally 100% accounted for. 100%. That's my statement. Now, I would like to be peer-reviewed on that, but that is, if you can come up with any argument against anything that I have said, other than, oh, there's nothing there, we proved there's no ether, oh, there's no ether. Well, let me ask you what. How does that light get to Earth? What heats your face when something hits you from the sun? What interacts with a solar panel that causes electricity to be generated? It's not nothing. It's a wave, it's a photon. Well, how does that photon move? What is the mechanism for that photon to get from there to here? Well, it's an electrostatic toroidal. Well, how does it move? What is it made of? Well, it's made of nothing. How could nothing move? Well, you don't understand. That's right, I don't understand. How does nothing move from the sun to the earth and create heat and light and all the things we see? If it's nothing between the sun to here, and there's nothing at all out there, how does it happen? They cannot answer that, and you can't answer it, and nobody can answer it, because it's not reality. It is particles cascading to earth, spinning to earth, and then being sucked to earth by a positive core. That's how it works. And an atomic bomb, I will show you how an atomic bomb can demonstrate this very clearly. Alright, now what you've been looking at is literally supposed to be light particles. Now the particle would be deep in the center of the disk, and the field that it presents is external to the disk. So this is nothing more than the particles that are in the air. This is not the particle. This is the particle. Now, what is this? That was that white blobby looking particle. It had no field. It didn't have one of these. What is it doing here? Why is this glowy like these things, only it's a no field? I believe this particle is spinning backwards. Now, there's a right-hand rule, and if it doesn't follow the right-hand rule, it will crush its own field. And that's what's happening to Venus. And I'm going to explain all the anomalies on Venus, which I did in a video just recently. But now that I can show this with the electronic interactions, it should make more sense. Now, this particle is now presenting its own little fieldish looking thing How, I don't know what it did, whether it started to step backwards or flipped or crushed into this and lost some energy. What it did, I don't know. But I can see that it apparently is giving off another field similar to these fields, which I would think, although I don't know, that could have been a whole nother field, and this is overtaking it and sucking it into itself and giving this off of the edge. I don't know. But I do know one thing. In my own mind, it could be wrong, is that the electronic interactions of every single thing that we observe is nothing more than the ether that surrounds everything bumping into something else, rubbing something. There's electrons here, electrons here. There's heat now. If I take chemistry and I add them together, they spit out heat sometimes. If I take cold and I suck something off of electrons, if I suck the electrons out, it will get cold, it will lose electrons, and they'll be less energetic, they'll be all floating freely. If I add electricity to anything, it heats it up, and they start shaking, say, somebody's coming in here, get me out of here. And they turn energetic, and they glow. Now, why they glow, this I am still working on, but I do have evidence of that. Rod has evidence of that as well. It was absolutely phenomenal, the work he did, and nobody would ever have a clue about this. Nobody would ever have a clue about this, because nobody would look at it. So let's see what he did on the other thing. Now, I just want to show you this, because this is not a one-time thing. These are particles coming out of the accelerator, which is here, and then they slow down like a wagon wheel, spins, and then it stops, and then it goes the other way. That it's like that, I'm telling you. It's spinning, and then it takes off. Now, in this interim, you can see it seems to be two waves, boop, boop, and then it goes back to a different architecture of the pulse, of the particle. Hold on a second. Alright, this is the most fabulous shot right here. You remember how I say everybody's in each other's regions, they're glowing, they're crushed, they're excited, they're in trouble here. Now, at this point they start to step down. Now he catches these two waves. And these two they look like the old atomic symbol from the 50s. That's all I can tell you. Look at that. Right? Now, I have theories on this, and I believe this is got something to do with capacitive and inductive reactance. And it's got to do, basically, anybody that understands the way AC pulses happen and how fields build and how they collapse knows that capacitance is the ability to absorb electrons, electricity, capacity, and inductance is the opposition to the flow of that electricity. If you know what a torus looks like, it has two bulbous things hanging around the side, and they all converge into the center, and it wraps down, and it comes back out the other side. That is like a hollow earth. What is happening here, to my way of thinking, is the magnetic field fills up the capacitance, then it tries to enter that choke, which is the inductor, which is the inductance, because it's now crushing down the field, because it's coming in with a big field saying, hey, let's go, everybody, come on. And it's like, whoa. It clamps it down. And then they pile up like they're all standing up on top of each other, saying, come on, push. And he says, no. And it keeps getting bigger. And then all of a sudden, if you shut off this flow here, they all go flying backwards. They'll all go this way. Now, I think they're going to come back in this side. And they'll keep coming, come on, go that way then. And they say, no, I can't go this way either. And after a while, they build up and poof, they go back the other way. That's what I am seeing here. And then you see a little spike. I have a better shot, a real close-up. Hold on. All right, this is a little more information on the nature of light. It spins forward in a circle. It's a particle spinning little bitty, 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 bitty like that. And when it goes through that accelerator, it goes flying off to the sides. So if it comes spinning this way and it goes through the bottom, it comes out over here. If it's a little extra this way, it comes here, a little more this way. But it's coming through that slot. And there's 2 slots. Okay. Now, if it hits coming through, and instead of coming through the bottom, it hits coming through the top, it goes this way. And that's why you see this. It's like a drill going through, and all they are is particles. And they're really only in the center. They're not way out here. Those are ones that were deflected. And so that's why you don't have this big, intense glow there. It's a screw procedure. Just like this, I've shown it a bunch of times. Hold on. Alright, this is exactly what happens with light. It gets so reactive that it throws itself out as a particle. Now, this is the trace the particle will follow. It'll go around like this, and then it will only reach a certain diameter and a certain speed. At that certain diameter and speed, and it might be way out like this, or it might be real tight up like this. And it depends on how tight it is, will be how fast it was thrown away. It'll go the same speed, basically, let's say, only this one will be spinning a zillion miles an hour. It got twisted like that when it went off. And this one might spit out straight off and not be going quite so fast, and it will be red light. So, and this is the particle tip. It just spins and spins until it hits something, and then it becomes light. So it's not like you're looking at it and it changes it. You're looking at it, and when it hits your eyeball, it turns into doing exactly what it's supposed to do. It's supposed to slap your eyeball and turn it into light, because it's energy. You don't see energy until it hits something. It's not energy. It's just sitting, waiting, saying, you want me to do something? No, just wait there. Well, I'm just static, man. I know that. Just wait there. Don't worry. A guy will walk by and he'll grab you. Just jump right on him. He said, what do you want me to do then? Well, get next to somewhere you could jump the ground, man. Just jump right off there. You shock the hell out of that guy. He could have jumped. You know, and that's what happens. The electrons are just looking for something to do. When they come through the atmosphere during the day, extreme volumes of them, and extreme straight on to you. You know that when the sun is hitting you straight on, it's hitting you straight on, and that's because it's coming at you straight. All right, it's not ricocheting off you at that point. And when it does, those electrons are slapping you hard, and they turn your skin red, and they burn you, and they cause all kinds of things. So that's the nature of light as far as I'm concerned. This is the right-hand rule. This is just after the accelerator, prior to presenting the disks. It's spinning to the right, drifting to the left, separated here, compressing here, and it will all of a sudden blossom into a Higgs field. Alright, there's 31,000 people now on Mudfossil University. We learn from each other. Nobody is a teacher. We're all students. Renz, my friend in France, sent me this picture. He took his thumb just like this and took this picture, blocking the sun from his lens completely, and he caught this disc spiraling from his thumb, not much smaller than his thumb. And look carefully now. This is really critical. This is white light, which the sun is the white light. We understand that. It's all the frequencies of light. But what happened here? Dark, dark blue, green, red, blue, green, red, blue, green, reddish into the lilac color. Now, I'm going to show you what it says about that. Alright, here's an article right here. This is about leptons, colored leptons. And it is exactly the colors we saw. Listen to this. If leptons are composite, and if they contain colored preons, one expects the existence of heavy color octet fermions with quantum numbers similar to those of ordinary leptons. Oh yeah, you know, everyday ordinary lepton. Such a colored lepton, which I just showed you, should decay into a gluon and a lepton. There's no gluons because there's no neutrons. yielding a unique experimental signature. Charged color leptons probably have mass of the order of, at this point it's just all guesses. Now, let's see what the colors they expect to see. Alright, this is from Quora. These are particles, leptons and quarks. Same colors we're talking about. They're talking about, we're talking electrons. So they're talking heavy particles, we're talking electrons. Then in the quarks is what we're also talking about. So go down into these colors. You see this? This is the colors that we're seeing coming off of Ren's finger. Alright, this is what I am displaying. Electron neutrinos, which give electron showers. Obviously what I had shown. You got the particle coming, which was that little white filament, the boson charged particle carrier. Now, it hits, they're showing it differently than it really is. It is still the particle, but when it crashes into the ether, it expands the ether into a round circular cone surrounding that as it goes forward. And there's so many of them coming together that they look like a shower. So it's not one creating all those. It's a whole batch of them coming through and creating all the showers in these exactly identical to that. And there's no difference whatsoever. And they say the Cherenkov radiation, exactly what I'm saying, is that white glowy radiation, and I'll show you that in a nuclear reactor, one more second, from the Cherenkov radiation from the electron shower produced by an electron neutrino event, which is just nothing but a whole batch of lights. Electrons. From that neutrino event produces multiple cones, multiple electrons, and therefore a diffusing ring in a detector array, which is what we have seen. Alright, that's Cherenkov radiation. Now, what happens is you see that glowy white, you know that something is being totally blasted with electrons. They are invading each other's regions with vengeance. They are attacking in strength. They are literally obliterating everything in its path, crushing it into a mad plasma of white Cherenkov radiation, shown in the light acceleration experiments I showed. Okay, this is Latham's Crazy Toys and Crazy Machines, and here's what happens. That's how a magnet can pull and hold at bay, and that is identical to what is happening in the nucleus of every atom. The nucleus is positive and negative crushed together and exceeding its negative neutrality, basically holding this at bay, and for some reason still completely pulling. And you can see it's obvious what's happening. So the nuclear core is both positive and negative, excessively negative, holding the additional negatives at bay surrounding it. That is heat when he shakes it. Sitting is rest mass. That's heat. It's getting hotter and hotter and hotter, and eventually it will fly off, and when it does, it is light. And the reason it is doing these interactions is because somebody is pumping electrons in, either with more light, or through a circuit with electricity, or through vibration, or through hammering, or whatever. It is forcing electrons into that region, forcing that electron to cause heat or light or both. Alright, this is Guide Wiki, and this is a nuclear blast, and here's what's happening. There's all of your electrons given off, because what you have is a nuclear core that has everything, tons and tons and tons of everything in there, but there is no neutrons, so it's got positives and negatives. And when it forces it together, the negatives are all in each other's regions. They go flying away as that intense light, causing extreme damage, way beyond what they think light can do, because they only think it can go to the speed of light, and they only think it has so much mass, and it has far greater abilities, they think, and it continues to radiate outwards like a normal bomb would. Now what happens? We see these rings form. That is radiation ionizing the rings in the air, and the glow of that nuclear core now is rising straight off the ground, and it is extremely brilliant, and I will tell you why it's brilliant. It is brilliant because it no longer has electrons. They are all now gone. Now it says, whoa, we got rid of all our electrons. We got to get some electrons back. Otherwise, we're going to go into outer space. Because it now has forced itself away. We know that the Earth is positive. We know that a nucleus is positive heavily, and it can force away negatives, but it can also force away a positive if there was a positive trying to hit it. And that's what's happening here, because that became positive when it lost all its electrons. Now it's heading up into space, and it said, I need electrons, suck them back around and bring them back into me. I will glow as you bring them back to me, because I will be heated, I will be extremely energetic, and I will just continue to go up in the air and drag everything with me. I will suck all these electrons back into my core, because I am not complete matter anymore. That is the nature of the nuclear blast. No reason for that to be glowing like that up there after it had expended its energy here. It is reconstituting itself. That's my statements, and I don't see how anybody can counteract that with logical, rational thought. Alright, I told you I'd do a backstory about Rod and so forth. I just don't have time to do it today. I have how it's done in one of these, Aether and Venus, which you should watch these, because every bit of these has something extra that I might have missed this time, or was additional, or I didn't understand at that time, and now it's understood. It's an evolving process. This is the Aether of Venus, and that's why it's spinning backwards, creating all that heat and all this. This is the solar system explained, exactly how we've traveled through, because we're being dragged on the arm of a Milky Way. This is about black holes and how they actually work, about photons in the Higgs field, galactic spirals, how the galaxy spins, sprites, John Glenn's fireflies. You should see that, because that is light too. So go up here, you'll see how Rod did his stuff. Go up to Mud Fossil University on YouTube. Alright? Thank you.